Today we're working on dilations and specifically creating constructions of dilations. I've already done a couple of these. So the first one shows X, which is a center of dilation, and our pre-image, triangle A, B, C, shown in blue. In concept, X is the center of dilation. You can think about it as a flashlight. It's shining on this triangle and expressing the triangle up, for instance, against a wall. Think of shadow puppets, putting your hand in front of the flashlight and it shoots up an image on the far wall. So if I think about from this X emitting a beam of light past A, infinitely long, similarly from X past B and from X past C, all I'm going to do is apply the scale factor, in this case a scale factor of 2, along this length. So instead of going a distance of 1 unit, which is XA unit long, I'm going to take my compass and open it up to be exactly XA units long. Then when I pick that up and copy it to A and make my mark, it shows me how far along this ray I should go to create A prime. Similarly, I'll expand this to show me what XB is. Then I'll copy that length there, giving me where B prime is. And similarly for C, if I adjust my compass to measure XC, and then I copy that length to create C prime, when I connect those, I produce A prime, B prime, C prime. And what I then know is that triangle ABC is similar to the triangle known as triangle A prime, B prime, C prime. Because the scale factor is equal to 2, we can say it's an enlargement. Remember that when the scale factor is greater than 1, it's an enlargement, and when it's between 1 and 0, it's a reduction. The second one here is in fact a reduction. We begin with a scale factor of 1/2, which we know will give us a reduction. And I began with my pencil triangle here, ABC, a really large triangle, and I chose a center of dilation inside the shape, on the interior of the triangle. And because I chose a scale factor of 1/2, all I had to do was extend my ray of light, X through B, but instead of going past it, I made my perpendicular bisector to find the midpoint of B prime. I did the same here, extending a line from X through A, and then I created my perpendicular bisector to find A prime, and X to C, and made my perpendicular bisector C prime. When I connect those, I get my triangle, which is similar, triangle ABC, is similar to triangle A prime, B prime, C prime. The scale factor is 1/2, making this a reduction. Lastly, the challenge was to produce one with a scale factor of 3.5. So I have my starting point, which is my center of dilation. I have my center of dilation, I have my triangle ABC, and I want to extend the light beams coming out to show how X is going to be applied, how the center of dilation will be applied. So I'll begin by taking X through each of the values, take X all the way through A, and what I need to find is a distance that's not one of these units, but 3.5 units out. So I'll take my compass and I'll mark exactly what length XA is. And then I'll copy that. There is 2, and there is 3 of them. And I want to get 3.5. Well, that's 4 of them. This is 1 length. This is 2 lengths. This is 3 lengths. So my 4th one is too far. I need to be in the middle here. Well, I can come back and do a construction of an angle of a segment bisector. In other words, I can find the midpoint between the 3rd and the 4th segments. And if I find that midpoint exactly halfway between 3 and 4, should be 3.5. So that's my point A prime. I can then do the same thing from B. I go X through B, and then I'm going to measure the distance from XB and copy it so that it becomes 3.5 times as far away, or as long. I open up from X all the way to B, make my mark, and then I go 2, 3, 4 times away, and then I come back and say I want to back off half of that. So I'll make my perpendicular bisector, and I don't really care about the perpendicular nature. What I care about is the bisector nature. I'm going to want to bisect this segment between 3 and 4 because that would be 1, 2, 3, 3.5 units away. So there's my B prime. I'll do the same thing with my C. I begin with the length of A to C as 1 unit, 2 units, 3 units, 4 units. I want to back it off just a bit, so I'll come back at the 4th and make my perpendicular bisector between the 3 and the 4. And when I construct my midpoint based on that, that's my point C prime. If I were to then construct, using my straight edge, the segments connecting A prime and C prime, and C prime and B prime, and B prime and A prime, I produce my triangle such that triangle ABC is similar to triangle A prime, B prime, C prime. Scale factor is 3.5. Therefore, even though it's got a fraction to it, the overall number is larger than 1. Therefore, it's an enlargement. Hope this helps.